Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra 2 Common Core Regents. So here is part 3. We're doing this one question at a time. Here's question 33. On the set of axes below, graph y equals f of x and y equals g of x for the given functions. So we have f of x equals x cubed minus 3x squared, and then g of x equals 2x minus 5. So I'm just going to plug in f of x and then find the table. X cubed minus 3x squared. So let's see what that looks like on the graph. So it looks something like this. So let's just check out the table, go second table. And we could write out a little table of values for f of x. So we're just getting our coordinate points off of here. So let's go back a little bit. We could see -2, because our -2. And just go up from there. So you see -2 is paired with -20. So now let's just graph the coordinates of this function from our table. So we have 1, -2. So then when we look back at our picture, we can see that it makes this kind of a shape. Okay, so we have f of x. Now let's do g of x. So this time this is just a line, so we can just take a look at this. We see that the y-intercept is at -5, so we're just going to start there. And then the slope is 2, so that means we're going to go up 2 and to the right 1. So we'll go 1, 2, over 1, and 2. And then going the other way in the opposite direction. And then just labeling our graph, we have g of x here and f of x here. And so now we graphed our functions. So let's now see, what are they asking us? State the number of solutions to the equation f of x equals g of x. So the number of solutions is just where these two functions intersect. So you could see that they intersect 3 times. So we have one spot over here, one spot over here, one spot over here. So our answer is 3 solutions. Question 34. A Foucault pendulum can be used to demonstrate that the Earth rotates. The time t in seconds that it takes for one swing or period of the pendulum can be modeled by the equation t equals 2 pi, the square root of L over g, where L is the length of the pendulum in meters, and g is the constant 9.81 meters per second squared. The first Foucault pendulum was constructed in 1851 and has a pendulum length of 67 meters, determined to the nearest tenth of a second the time it takes this pendulum to complete one swing. So I'm going to write out what all these different parameters mean in our given formula. So we have this formula, t equals 2 pi times the square root of L over g. And I'm just going to write on the left here what each thing represents. It tells us that t is the time in seconds. It tells us that L is the length of the pendulum in meters. And it also tells us that g is a constant, so that means it doesn't change, which is just 9.81 meters per second squared. So now when we look at this problem, we can maybe fill in what these each mean. So it's constructed and has a pendulum length, so it gives us the length in this part of the problem is 67. And they want us to determine the nearest tenth of a second, so we want to find t. So we're going to leave t open and set it equal to 2 pi times the square root of L, which they give us is 67, all over g, which is a constant, 9.81. So now we just need to plug this into our calculator. And they want it to the nearest tenth of a second, so you can see that's just going to be 16.4 seconds. So the second part of this question, let's take a look at that. Another Foucault pendulum at the United Nations building takes 9.6 seconds to complete one swing. So this time they're giving us what t is equal to. So t is equal to 9.6 seconds. Determine to the nearest tenth of a meter the length. So we need to find the length this time of the pendulum. And g is going to be that same constant, 9.81. So now we'll just bring down that formula they give us. And we're just going to plug in what we have. So we have t, which is 9.6, is equal to 2 pi times the square root of L, which we don't know. So we're just going to leave that as L, all over g, which is 9.81. So now we're just going to solve this like any other regular algebra problem with a square root. So we'll divide by 2 pi first on both sides. You'll see that we get this really long number. I'm just going to write the whole thing out so we don't have any rounding issues. So now to get rid of the square root, we just have to square both sides. So we'll square it in the calculator and then we get this, another long number here. And then we could just cross multiply 9.81 times this number to get the value for L. So we see that L is equal to 22.9, and they want it to the nearest tenth of a meter. So we're good, so 22.9 meters. So just a little trick for whenever you're given a formula that is new to you and you're not sure what everything means, I always like to write it out. I think that makes it much easier for picking out what numbers represent which letter and then filling it into the formula. So just a little tip, even though it takes a little bit longer, I think it makes your life and the confidence in your answer so much better. On to question 35. In order to decrease the percentage of its residents who drive to work, a large city launches a campaign to encourage people to use public transportation instead. Before starting the campaign, the city's Department of Transportation uses census data to estimate that 65% of its residents drive to work. The Department of Transportation conducts a simulation shown below around 400 times based on this estimate. Each dot represents the proportion of 200 randomly selected residents who drive to work. So we have the mean is 0.651, which is about in the center, and then standard deviation is 0.034. So let's look at what they're asking us. The first question, use the simulation results to construct a plausible interval containing the middle 95% of the data. Round your answer to the nearest hundredth. So I want to, even though this is all here, I want to draw a normal curve of my own, where the mean is in the center, 0.651, and then if we go up one standard deviation, so we're adding on 0.034, we're going to get 0.685. And then if we add on another standard deviation, we're going to get 0.719. And if we go the other way, we're subtracting. So 0.651 minus the standard deviation, 0.034, we're going to get 0.617. And then if we go one more standard deviation below, 0.617 minus 0.034, again, we'll get 0.583. So they want to know the middle 95% of the data. So if we go back and look at our bell curve, 95% of the data, if we added all these up, 34.1% plus 34.1%, and then plus 13.6% plus 13.6%, this would be about 95%. So this whole area in here is about 95%. And this is 2 standard deviations up and 2 standard deviations down, which is exactly the interval we just found. So right in here is 95% of the data. So they want to know the interval. So that would just be these guys right here. So it's from here to here. But they did be careful because they want it to the nearest hundredth. So that's 0.58 to 0.72. And that's our answer. And just a quick refresh if you forget about how to use the bell curve. This is the mean, and then when we say we went 1 standard deviation up, it's a unit of measurement that they give us that measures each data point in relation to the mean. So when they give us this 0.034, that I'm just adding this way and then subtracting this way. And that's where these numbers came from. Okay, so let's look at the second part of this question. 1 year after launching the campaign, the Department of Transportation conducts a survey of 200 randomly selected city residents and finds that 122 of them drive to work. Should the department conclude that the city's campaign was effective, use statistical evidence from the simulation to explain your answer. So here, they're saying that 122 out of 200 people are still driving to work, and they're trying to encourage people to not drive to work anymore. So let's see, 122 divided by 200, that's 0.61. So if we look at our interval here, this number is included in there, right? So we want less people to be driving to work. We don't want this to be included in the 95% of the population to still be driving. So we say no. So in our answer, we just write no, 0.61 of people driving still falls in the middle of 95% of the sample. So yeah, and I added the words this sample because it's this particular sample that they chose, 122 people out of the 200 randomly selected city residents. So maybe they would get something different out of a different randomly selected sample. So we don't know, but based on this sample, it doesn't look like their campaign is working very well. Question 36. Solve the system of equations algebraically. So this is a nice classic question. So I'm just going to start by rewriting our 2 equations that they give us. So notice that this one, the second equation, we can rewrite this in terms of y equals, and then plug that into here. So when we do that, we'll get to y equals 2x minus 5. And now we're going to take this and plug it in there. So we have x squared plus y squared equals 25. But now we're plugging in 2x minus 5 for y. So this becomes 2x minus 5 squared equals 25. So we're just going to expand this. We can combine like terms here. You can see that these 25s are going to cancel out. And then now we can just take out a GCF here of 5x. And then set this equal to 0 and solve for x. When we do that, we'll get x equals 0 and x equals 4. So remember, we're not just factoring here, we're just trying to solve the system of equations. So we found 2 values for x, so let's plug these into the original equation and solve for y. So using that first equation, x squared plus y squared equals 25, but now we're going to plug in 0 for x. And we could see that y is going to be equal to 5. So we know that one pair of solutions is 0, 5, where we have 0 for x and then y for y. So we know that this is one of our answers. And now let's find our other solution where we plug in x equals 4. So start with that first equation again, x squared plus y squared equals 25. And then now we're just going to plug in 4 for that x squared. So 4 squared plus y squared. So now we have this other pair of 4 and 3, where x is 4 and y is equal to 3. So we have two solutions for this question, 0, 5, and 4, 3. Our last question, question 37. The population in millions of people of the United States can be represented by the recursive formula below, where a sub 0 represents the population in 1910, and n represents the number of years since 1910. Identify the percentage of the annual rate of growth from the equation a sub n equals 1.015 times a sub n minus 1. So we want to find the annual rate of growth. So you can kind of think of this as a growth function or even a geometric sequence. Because notice we're just multiplying the rate here. This is the rate, and then this is the previous term, or the value of the previous year. Right, so a sub n minus 1, and that would be 92.2 times the rate. So this is the rate. But when you think of a growth rate equation, it looks something like this. So our rate is always here, but it's always being added to 1, right? So this, all we have to do to find our rate from year to year is to subtract 1. And this will give us our rate. And when we do that, we'll get 0.015 and then times 100, which will just give us 1.5%. So there's a little bit of a connection of thinking this is a geometric sequence and then an exponential growth function as well. So next part of this question, write an exponential function p, where p of t represents the United States population in millions of people, and t is the number of years since 1910. So we have p of t, and we just kind of wrote out what an exponential function is over here. So here we have our initial value, which is 92.2. So we can put that in, 92.2, times 1 plus r, which is our rate, which they give us as 1.015, and then raised to the t, the number of years. So that's it for this answer right here. And now for the last part. According to this model, determine algebraically the number of years it takes for the population of the United States to be approximately 300 million people. Round your answer to the nearest year. So we want to look at and use our formula. So basically we want to find out the number of years, which is t. How much it would take to approximate 300 million people. So it said earlier the population is in millions up here, so we could just set this equal to, we have 300 equal to, and then we have our initial value 92.2 times our rate 1.015 raised to the t, which is what we're going to need to find. So now we could just solve this like any other normal algebra question, dividing 92.2 on both sides. When we do that, we get this long number, 3.25. So now we have this unknown value for t as an exponent, so we're going to have to use log. So we're going to do the log of the number we just found and set it equal to t times the log of. So this just bringing this exponent t to the other side and multiplying it. That's one of those log rules. I have a whole video on that if you want to check that out. And now we could just divide by log of 1.015 to get t alone. And we get that t is equal to 79.43. But notice when we look back, they want it to the nearest year. So we can just say that it'll take 79 years to have a population of 300 million people. And that's our answer. So this is the last question of our test, so I hope this has been really helpful for you. I wish you good luck on the upcoming test, and don't forget to check out, I have a cheat sheet and a bunch of related questions and videos all on MathSux.org. Happy calculating! So if you're looking for more on this test, check out the playlist in the link below. And thanks for stopping by. Happy calculating! Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!